Hi everyone, this is Mr. Savinel reviewing how to solve equations and formulas. For our first problem, we'll solve for k, so we can combine like terms right there, negative 6 plus 1. We have negative k minus 5 is equal to negative 4. Going further, we can add 5 to both sides. Be careful with adding and subtracting positives and negatives. We'll have 1 is equal to negative k, so dividing by negative 1, we'll get k is negative 1. Next problem, we're solving for a, so we can combine like terms right here and rewrite the problem as 8 minus 9a is equal to negative 19. So when we take away 8 from both sides, we'll have negative 9a is equal to negative 27. Getting the a by itself, we'll divide by negative 9 to both sides, and we'll get a, the variable a, equals 3. In this problem, we have to distribute the negative 6 first, so we're multiplying. That negative 6 goes to both terms in the parentheses. We have negative 42p. Then the negative times the negative is positive. 6 times 1, 6. Minus 8p is negative 94. So going further, we could combine like terms. We have the negative 42 minus 8p, so that's negative 50p, plus 6 is equal to negative 94. So when we take away 6 from both sides, we'll get negative 50p is equal to negative 100. So dividing by negative 50, p equals 2. In this problem, the first step is to distribute. So distributing the negative, there's really a negative 1 there, so that becomes negative m. Negative times negative is positive 1. I'm going to distribute, now distributing the negative 5 to both of these terms. We'll have minus, because negative and minus are the same word, negative 5m minus minus is plus 20. And that's equal to 57. Going further, combine like terms, we have negative m minus 5m, negative 6m, plus, combining the 1 and the 20, 21 is equal to 57. Going further, if we take away 21, we're left with 36 is negative 6m. So dividing by negative 6 to both sides, we'll get m equals negative 6. Solving this one, if I distribute, I'll have 2 plus 8a. Distribute the negative, there's negative 1, negative 3a plus 1 is equal to 18. Combining like terms, I have 3 plus 5a is equal to 18. Take away 3 from both sides. 5a is 15. Divide by 5. a is 3. So the answer is a is 3. When I take a look at this one, it really looks like a nightmare with 7/5, 1 and 2/3. I have a mixed number in there, a denominator of 24. Okay, so trying to think of a better way to do this. A trick to do this is to find the lowest common denominator of all of the fractions. So the denominators are a 5, 3, 24, and 4. So the lowest common number, which is divisible by those numbers, is 120. I got that by multiplying 5 times 24, and knowing that 3 and 4 are divisible into that also. So I'm going to rewrite this problem. So in rewriting it, all I did was change this negative 1 and 2/3 here to 5/3, to the improper fraction 5/3. Alright, now what I'm going to do is multiply all of these by this LCD of 120. And the reason I do that is then the problem will no longer have any fractions. So in doing it, 120 times 7 divided by 5 is 168. So I'll have 168n plus 120 minus 200 is equal to 245 plus 90. So now the problem's much more manageable because I don't have any fractions. So going further, I'll have 168n minus 80 is equal to 335. So when I add 80 to both sides, that means that I'll have 168n is equal to 415. So divide by 168, and that means that n is equal to approximately 2.47. Doing the same method for this problem, I have denominators of 4, 5, and 20, so my least common denominator is 20. That means I'm going to multiply this whole equation through by 20, and I will get this equation right here with no more denominators. That's just multiplying 20 to this term, to that term, this term, that term, this term, and that term. Multiplying all those terms by 20, and I got that following equation. So simplifying the right side up a little bit, negative 24m plus 25m is m plus 53. Okay, so then going further with this, when we take away m from both sides, we'll have negative 66m, and take away 20 from both sides is equal to 33. So dividing by negative 66, we'll get that m is equal to negative 1/2. In this problem, we have x on both sides, so distributing, we'll have negative times negative 12x plus 12, negative times negative, minus x minus 2, that's distributing the negative, is equal to 6x plus 7x is 13x. Okay, so simplifying, I'll have combined like terms, 11x plus 10 is equal to 13x. When you take away 11x from both sides, I'll have that 2x is equal to 10, so x is equal to 5. In this problem, we can distribute the negative 3, get negative 3p minus 6 is equal to 4 minus 4p. So going further, if I add 4p to both sides, there's multiple ways to solve this, but one way would be to add 4p to both sides. P minus 6 is equal to 4, so adding 6 to both sides, p is equal to 10. Here's an important skill for us to solve formulas for particular variables. xm is equal to pn. We're looking to get x by itself, so what are we doing to the x? We are multiplying x by the number m, whatever m is. So in order to undo multiply by m, we have to divide by n, by m. So dividing by m, divide by m, m's cancel, x is equal to pn divided by m. Now we've solved for that x. In this problem we're solving for a, so if I highlight that A's not going to move, everything else will, so we have to undo the plus k. So minus k to both sides of the equals. Those are unlike terms, so when the k's go away, we have A is equal to v plus w minus k. And we have that A by itself. In this problem, we're solving for a, so circle the a. The a does not move, everything else does. So we have to undo the minus b first. The order here is important. So to undo minus b, we're going to add b. Then the b's cancel, and we have z plus b is equal to am. Again, circle the a doesn't move, everything else does. So divide by the m, and you get that a is equal to z plus b divided by m. Last problem, we're going to circle the x. The x does not move, everything else does. We have to move over the other term to the other side first, so plus y. When I rewrite that, I'll have z plus y is equal to m over x. So next I'm going to undo the m, so I'll divide by m to both sides. So dividing by m, dividing by m. So the m's cancel, and I have 1 over x is equal to z plus y over m. That allows me to do a reciprocal rule where I can flip both fractions. So now I'll have x over 1, or simply x, is equal to m over z plus y. And that's my answer. X is equal to m divided by z plus y.